Welcome to the Crazy Hat Chemist. So another video on atomic structure and electron configurations. BAM! So the photoelectric effect, the particle nature of light. Okay, here is Einstein's experiment explained. When light with a minimum energy strikes a photosensitive surface, electrons are ejected. The ejected electrons cause an electric current to flow as a result, and this is what is measured. The light with lower frequencies do not have enough energy to eject or remove electrons. That is, light with energy below a certain threshold does not eject electrons, and no current flows resultingly. Okay? There are no electrons that are ejected until light with enough energy strikes the surface. Light with greater than the minimum amount of threshold energy will eject electrons, but not light with lower than the minimum threshold energy. The number of ejected electrons depends on the light intensity. Okay? So, still photoelectric effect. The classical theory said that energy of an ejected electron should increase with increase in light intensity. That was Max Planck's observations. Look at the previous video. However, this was not what was observed by Albert Einstein in the photoelectric effect experiment. Okay, what he did is the photoelectric effect demonstrates the particle nature of light, i.e. that light consists of particles called photons, which are discrete packets of energy. Therefore, the following equations are used. Okay? Hopefully you've already seen this one. This is Max Planck's equation. That is, energy is equal to Planck's constant times the frequency. We've already seen this one as well. That is, the speed of light is equal to the wavelength times the frequency. So what we're going to do is we're going to rearrange that bottom equation and solve for the common variable between these two equations. So I've rearranged the bottom equations to solve for nu, which is the frequency. The frequency is in both equations. Now I'm going to substitute in c over lambda, that is the speed of light over the wavelength, into the frequency in Planck's equation. Okay? Now I'm going to have a new equation. This is the new equation. That is, the energy is equal to Planck's constant times the speed of light divided by the wavelength. Okay? So what this states here is, if you look at that picture of gears on a bicycle, I'm hoping that you get this analogy. And that is the following. This is what Einstein discovered here in the photoelectric effect. Okay? So I'm hoping that you're familiar with the bicycle and the cogs in the back of the bicycle, and there you have a derailleur, and that chain is moved by the derailleur, and that derailleur is only moved in certain locations where that chain can be. That chain cannot be in between the cogs on the back of that wheel. The chain can be only on the cogs, and that is it. That is, there are certain steps of which you can have a photon within an atom. You cannot have them in between. If you try to move the derailleur over and it's not the amount of energy that is necessary, it will stay in the lower cog. Okay? If you move it over with enough energy, then it will get up to the next cog. If you imply more energy, then it will move into the next cog. But if you don't have enough energy, then it won't move into the next cog. It is not a continuous spectrum of which Max Planck found out and discovered with his observations. But with the photoelectric effect, there are certain packets of energy that are certain quanta of energy. These photons only exist at certain levels. This is an essential understanding for the atom itself. Okay? So here is Einstein's paper on which he published, okay, in 1905. Okay? Really cool stuff. Awesome stuff. Okay? Here's a little bit of across the fence humor, if you will. What do Albert Einstein and a cow have in common? Here's Albert Einstein. Here is a cow. They both stand out in their field. Okay, that was another Crazy Hat Chemist video, and I hope you enjoyed that. And today we are wearing a pizza hat because I have an Italian background, and I love going to Italy. So, if you like that video, give me a thumbs up, subscribe to my YouTube channel, and we will do some more cool chemistry next time. Bam!